Hello students, so we'll discuss a few more questions related to the chapter Haloalkanes and Haloarenes. Okay, the first question you can see a product is given, you need to find R dash X, then D and E. Okay, that is what you need to find. So basically here you can see R dash X and Na ether. So this is an alkyl halide and this is sodium in presence of ether. This is basically Wurtz reaction. Okay, what is Wurtz reaction? We have two molecules of an alkyl halide in the presence of Na ether. This R and R will couple. Okay, to form the product. See, this is the reaction, Wurtz reaction. Two molecules of alkyl halide. Rx is basically alkyl halide, right? So, two molecules of alkyl halide in the presence of Na and ether, what it forms is RR. Basically, R of one Rx and R of the other Rx, it will combine to form RR. Okay, so there's a coupling, right? So, in this case, if that is the case, this is also Wurtz reaction. So, what would be the product here? You can see this is one R group and this is one R group. So basically it will be like this CH3, 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 X. Then the other molecule will also be CH3, 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 X. Okay. So basically what will be R dash? R dash will be this is. So basically R dash is CH3, 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 CX. Okay. So that is what two molecules of this will react to form this compound. Okay. So this is the Wurtz reaction. And then when you in the presence of magnesium, what would happen? I have already discussed, like when you have alkyl halide and Mg, what will be formed? The Grignard reagent. Okay, Grignard reagent. So here what will be the product? So I hope this is clear. Basically, in this X, in front of X you get an Mg. Okay. So this is alkyl halide plus Mg. We get Grignard reagent. What is Grignard reagent? RMgX. It will be having the format like RMgX. Okay, RMgX formed. So here this in presence of like in front of X you see magnesium. That is what happens in this. And then water. When water is passed, what will happen? This Mgx will be replaced with hydrogen. A similar question was discussed in the previous video. Okay, so here you get CH3, CH3 and hydrogen. Okay. Okay, so in the first case I said R dash X and Na ether. This is basically alkyl halide. So alkyl halide in presence of sodium ether. That is what is Wurtz reaction. So two molecules of alkyl halide in presence of sodium ether, what happens? This alkyls will combine. So you get RR. See, two molecules of Rx, Na in presence of Na and ether, you get RR. Okay. So basically here two molecules of this alkyl halide in the presence of sodium ether, it forms this compound. Okay, the coupling RR, the coupled product. And then when this R dash X in presence of magnesium, it forms Grignard reagent. So basically in front of X an Mg will be added. Okay, and then in presence of what happens? In the presence of water, what happens? This Mgx will be replaced with hydrogen. Okay, so that's it. But this is actually a contradictory question. You might have noticed this. The thing is that here you can see that as per NCERT, I think this is the answer expected. But the contradiction is that here you can see this is a tertiary halide. Okay, tertiary halide, undergoing this Wurtz reaction is less. What is the reason? Because CH3, all these are CH3, and you know CH3 is a bulky group. I have told you, like iodine, CH3, all these are bulky groups. Fluorine, all are small groups. So here all these CH3, see, to this carbon atom, three heavy groups are attached, three bulky groups are attached, CH3. And after the reaction, what happens? Again CH3, basically these two carbon atoms, you know, in these two carbon atoms CH3 is attached. So there will be like steric hindrance. So the case where this basically the reaction proceeding in this way will be like difficult. What is the reason? Because of this bulky group CH3. So the reaction to proceed, the reaction forming Wurtz basically here you can see Wurtz reaction is Wurtz reaction is what has happened, but strictly speaking, will that actually happen? That is a question, because CH3 is a bulky group, okay, and when you couple again, these two carbon atoms will be having CH3 near, so it will be having steric hindrance for sure, okay. So in the real scenario, when you can see what happens is basically an elimination or substitution will take place. Basically what happens is in sodium ether, what actually happens is basically this X and one hydrogen will go, basically dehydrohalogenation, okay, and then what you get is so the basically this reactant might form this, okay, this product, basically elimination product, it can form an elimination product, and the chance of proceeding in this way is less. What is the reason? Steric hindrance, okay, but I think the NCERT expects this answer. So this is actually a contradictory question, but let's look into it. So if you have any comments, you can write in the comments, okay, what do you feel about this question? Okay, and then we'll move into the second question. Predict the alkenes formed by dehydrohalogenation of halides with sodium, ether oxide, ethanol, and identify major alkene. Okay, predict the alkene. You know, alkenes are alkenes, so basically it will have carbon hydrogens. Predict the alkenes. What is an alkene? Alkene is basically, you'll have carbon, hydrogen. Then alkene, ene, so basically it will have a double bond, okay. So predict the alkenes formed by dehydrohalogenation. What is dehydrohalogenation? What is D? D means removal. Hydro meaning hydrogen is removed. Halogenation. Dehydrohalogenation. Halogen, you know halogen. So when it is dehydrohalogenation, basically it is removal of hydrogen and halide. So basically there will be removal of HX. Okay. So HX will be removed. So that is dehydrohalogenation of halides with sodium ether oxide. Okay. Now with names, you know, like you will have many reagents. With reagents you need to understand what is the compound. See, if sodium ether oxide, if you just write a sodium ether oxide, and you might be able to identify what is the reagent. You need to know the formula, what it is. Okay, that is really important. So in this you can see that sodium ether oxide. What is sodium ether oxide? Sodium, you know, it is Na, right? And what is ether oxide? You know, when you have eth, basically eth, two carbon atoms in the alkygen. So you know ethane is CH2CH3, right? Ethane is CH2CH3. So when it is ether oxide, you can say that okay, there will be two carbon atoms, fine. Then there is also oxide, so it will be oxygen. So with that you should be able to write the formula, like it is CH3 CH2 ONA. This is sodium ether oxide. Okay, so you have eth, so two carbon atoms, oxide, so you will have an oxygen, then you have sodium. In another way of writing it is like NOET. What is ET? ET is basically ethyl group, which is CH3CH2. Okay, CH2CH3. Okay, you can write it as NaOET or as CH3CH2ONA, whichever. It is basically ethyl group, CH2CH3. Okay. In ethanol, and what is ethanol? So two carbon atoms, all. So you have OH. So it is not specified, is it in second position, third position, like it's not 2 all or 3 all. So that means it is 1 all. 1 all, basically in first position you have OH. Okay, so what is ethanol? Ethanol, see, eth, so two carbon atoms and all. So you have OH. So CH3, CH2, if you number it as 1 and 2, in first position you have OH. Okay, so that is ethanol. And you need to identify the major alkene. Okay, so now let's look. The first question is 1-bromo 1-methyl cyclohexane. So from this you must be able to identify what is the structure, okay, from the question. So 1-bromo 1-methyl cyclohexane. Hexane meaning hex. So there are 6 carbon atoms. Okay, hex. So there are 6 carbon atoms. Okay, cyclo. So basically the 6 carbon atoms will be in a cyclic chain. Okay. Okay, so we can draw this. Hexane, so 6 carbon atoms, so cyclo. So the carbon chains will be in a cyclic structure. So you can draw a cyclic hexane. Okay. Draw it as. Okay. So you can number it 1, 2, 3, 4, 5 and 6. Okay, hexane, so 6 carbon atoms, cyclohexane. Okay. Then 1 bromo. So in first position you have bromine. 1 bromo, 1 methyl. So in the same first position you have methyl group. What is methyl group? CH3. You know, methane is CH4, methyl is CH3. Okay. Now what is the reaction? So you need to, now in the presence of sodium ethoxide and ethanol. So you write NaOET, ethanol is ETOH. Or if ET makes it confusing, you can write it as CH3 CH2ONA. Whichever you find it easy to learn, you can use either NaOET or CH3 CH2ONA. Okay, it's basically CH3 CH2OH. Okay, whatever you feel. Okay, so this reaction is basically beta elimination. Okay, what is this reaction? See, in this reagent, there is in the presence of NaOET and ETOH, basically sodium ethoxide in the presence of ethanol, what happens is, what you get is beta elimination. And what is beta elimination? See, here bromine attached to a carbon atom. Okay, bromine is attached to this carbon atom. So basically this carbon atom is alpha. Okay. So the carbon atom to which bromine is attached is alpha, and this carbon atom is beta. Okay. And this carbon is also beta. So carbon to which bromine is attached is alpha, then the adjacent carbon atoms will be beta. So this is beta, this is beta, this is also beta. Okay. So in this reaction, beta hydrogen elimination takes place. Okay, beta hydrogen elimination. So in this case, here you have 2 hydrogens, right? Carbon has valency 4. So here this carbon is attached to 2 other carbons. So rest there will be 2 hydrogens over here, right? And here also this carbon attached to 2 other carbons. So there will be more 2 hydrogens. And then the carbon valency of carbon, it satisfies as 4, right? So here you have 2 hydrogens, right? And this beta carbon has 3 hydrogens. Okay. So in the second and sixth positions, there are 2 beta hydrogens, and this methyl has 3 hydrogens. Okay. So this is basically beta hydrogen elimination. So and then this bromine will also go. So basically what happens is, hydrogen will go and bromide will go. Okay, basically it is the elimination of HBr, minus HBr. Okay, so when hydrogen from this beta carbon gets removed, what happens? It will come, this bond will be, it will become double bond. Okay, and this will go as bromide. Okay, so H will go as H plus. So this bond will shift to this side, and then Br will move as bromide. So basically the valence is also satisfied. So what do you get? Okay, this is what you get, CH3. Okay, so here 1, 2, 3. There was 2 hydrogens, now it is only 1 hydrogen. The other hydrogen got removed. Okay, so this is one product. Okay, and what is the other product? See, these both are identical, right? So the other product is, you can remove hydrogen from this carbon. Okay, so then what will you get? So these 2 are the products formed, but this will be the major one. And this will be the minor one. Okay. So what is the reason behind it? See here, here comes Seytz's rule. Seytz's rule, what it says is that carbon to which more alkyl groups are attached. Basically this is a double bonded carbons, right? This carbon and this carbon is a doubly bonded carbon atoms. So if these carbons have more alkyl groups attached to it, that will be having the major product. Okay. So here you can see that this is a carbon atom, this is another carbon atom. Okay. to this carbon atom 2 alkyl groups are attached, right? One CH3 and the other alkyl group of the cyclic chain. Okay, and to this carbon atom 1 alkyl group is attached and the other is hydrogen. So basically this is a tri-substituted one. Tri-substituted one. Basically you have one alkyl over here, one alkyl group over here, and one alkyl group over here, and one is hydrogen. Okay, so this is tri-substituted. Okay, in this case what you can see, doubly bond carbon atoms. Look at the doubly bond carbon atom. This is one carbon, this is the other carbon. So to this carbon atom 2 alkyl groups are attached, but to this carbon atom hydrogen is attached. So this is actual di-substituted one. So what does this Seytsev rule say? Seytsev rule, it says that if there are more alkyl groups attached to the doubly bond carbon atom, that will be the major product. So here this is a double bond, right? So this is a doubly bond carbon atom. This is one carbon, this is the other carbon. So the and then you have more alkyl groups attached to it. So this is a major product. Here to this carbon you don't have any alkyl group. Here you have hydrogen. So when you compare these two, this will be the major product. Okay, I hope this is clear. So the major product will be the one which has more alkyl groups attached to the doubly bonded carbon atoms. Okay, this is the doubly bonded carbon atoms. Okay, so this is a major one. So basically what happens is beta-elimination. What is beta? After elimination what you get is an alkene. So here you get alkene. That is why predict the alkene. So here there is a double bond. So we call it if there is a double bond, what you call it as an alkene, right? So predict the alkene formed by dehydrohalogenation. So here it is dehydrohalogen because what is the reason? Because HBr got removed. Here hydrogen got removed and that bond shifted, H plus was removed. So here you get a double bond and then Br minus got removed. Okay, so here dehydrohalogenation because hydrogen and bromine got removed. Okay, then with sodium ethoxide. Okay, sodium ethoxide in ethanol. So this is a major alkene formed. Okay, this is the first question. Now let's look into the second question. Okay, so first you need to identify the compound. Okay, 2-chloro-2-methyl-butane. Okay, what is butane? Butane basically it has 4 carbon atoms, right? In the alkyl chain will be having 4 carbon atoms. Okay, so let's draw butane. 1, 2, 3, 4. Okay, so you can number it 1, 2, 3 and 4. 2-chloro-2-methyl. So in second position you have chlorine. In second position you have methyl. Okay, so 2-chloro-2-methyl-butane. So basically butane 4 carbon atoms in that alkyl chain. So you draw 4 carbon atoms. Then again in second position you have chlorine. Second position chlorine. 2-methyl. So in second position again you have methyl group. See, I told you methyl is CH3. Methane is CH4. Okay, then you fill the rest with hydrogens. CH3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Now this also undergoes beta-elimination. Okay, beta-elimination. See, I told you beta-elimination because hydrogen from beta position is removed. Okay. Now let's look at, now first we need to find the beta hydrogens. Okay. So this is a halogen atom, and this halogen atom is attached to this carbon. So basically this is the alpha carbon, right? And this is the beta carbon. So carbon to which halogen is attached is alpha carbon, then the adjacent carbon will be the beta carbon. And this is also beta carbon. So two beta carbons have 3 hydrogens each, and the other beta carbon has 2 hydrogens each. So basically these both are identical, right? So we'll consider one of them and here the other one. So basically you get 2 products. What is that 2 products? One is when this hydrogen gets removed, you get a double bond over here. And then this chlorine also gets removed. Okay, the other product will be like this hydrogen gets removed. So you get a double bond over here. So let's look. You can write it as, basically this hydrogen will be in this form, right? This will come, if you write it in this way, you can write it in this way. Okay, so this, it will go as H plus and this is Cl minus, so basically HCl. You can write it as This is double bond. Okay, 1, 2, 3, 4. Okay, then what will be the other product? You can remove hydrogen from this carbon will go because this is a beta hydrogen, right? So we will write that. Three, 4, 1, 2, 3, 4. 3, 4, 1, 2, 3. 1, 2, 3, 4. 2, 3, 4. So, okay, this is the product, and what is the major product? Major product, this will be the major product, and this will be the minor product. Okay, so what did we do? Here, this is also beta hydrogen halogenation, so you need to remove the beta, hydrogen from the beta position. So here you have got two types of beta hydrogen. Okay, in one carbon atom has 3 beta hydrogen, and the other carbon atom has 2 beta hydrogens. Okay, so here you get 2 products. So when hydrogen from this carbon is removed, what you get is this product, and when hydrogen from this carbon is removed, you get this product. Okay, I hope this is clear. I don't think it needs further explanation. Okay, so here one is major and one is minor. See, based on again States of rule, when the doubly carbon atoms which has more alkyl groups attached, that will be the major product. Here you can see this is the double bond. Here this carbon has alkyl group, this carbon has one alkyl group and 1 hydrogen. Basically it has only 1 hydrogen, the rest are the alkyl groups, right? So basically try substitute, right? This carbon atom has 2 alkyl groups attached, this carbon atom has 1 alkyl group attached, and the other is hydrogen. So basically you have got 3 alkyl groups when you count. Okay, 3. And when you look at this carbon, these both are the doubly bonded carbon atoms, right? Here this carbon is attached to 2 alkyl groups, but this carbon is attached to hydrogens basically, so this is di-substituted. You have only 2 alkyl groups attached. When you count in total, you have only 2 alkyl groups attached to a doubly bond carbon atom. So basically this will be the major product. Okay, so I hope this is clear. Now we will look into the next question. What is the next question? 2,2,3 trimethyl 3-bromopentane. This will also undergo beta elimination. Sorry, it is beta elimination. Other way of saying it is dehydrohalogenation. Okay, either it is beta elimination or you can say it as dehydrohalogenation. Okay, so beta elimination or dehydrohalogenation. Okay, remember that. If I have said it in the wrong way, just ignore it. Basically you need to remember it is either beta elimination or you can say it as dehydrohalogenation. Okay, now let's look into the structure. 2,2,3 trimethyl 3-bromopentane. Pentane. So what is pentane? Pentane is basically a carbon chain having 5 carbon atoms. So we will draw pentane. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4 and 5. Okay. 2-chloro-2-methyl. So in second position you have chlorine. 2-methyl. Sorry. Okay. 2,2,3 trimethyl 3-bromopentane. Okay. Sorry. Okay, 2,2,3 trimethyl. So in second position you have methyl group, third position also you have methyl groups. Okay, so CH3, CH3. Okay, 2, second position you have methyl, 3 methyl. Okay. So 2,2,3 trimethyl. You have methyl groups in second position and third position. Okay, and then 3-bromopentane. Third position you have again bromine. Okay, third position you have bromine. So 2,2,3 trimethyl. 2,2,3 trimethyl CH3. Okay, then 3-bromo. Third position you have bromine. 3-bromopentane, 5 carbon atoms, 3, 4, 5. Okay, now fill the rest with hydrogens. 1 2 3 4 1 2 3 4 1 2 3 4 1 3 4. Okay, so now you will have to look into the beta hydrogen, find the alpha and beta hydrogens. Okay, so here where is the bromine attached? This is a bromine. Okay, bromine. So this is a alpha carbon atom. So this is a alpha carbon atom. So this is beta carbon. This is beta carbon. This is beta carbon. So this halogen attached to this carbon. So this is alpha carbon. Okay, and this the adjacent carbon atoms of alpha carbon will be the beta carbon. So this is beta. This is beta. This is beta. So you need to find the beta hydrogen is so what you need is beta hydrogen, right? So you can see that in this beta carbon there is no hydrogen attached. Okay, in this beta carbon there is no hydrogen attached, so you don't have to consider this carbon. Then the rest is these two carbons, these two beta carbons, so you have hydrogen attached, so you need to consider this case. So basically two products will be formed. The first product, you can see that hydrogen from this beta carbon will be removed and you will get a double bond over here and bromine will go. Okay, so here you get a double bond and here they won't be bond. That will be one product. The other product will be like this hydrogen will be removed, so here you will get a double bond and here you won't have bromine. Okay, so we'll draw the structure. So what will be the two products formed? Okay, let's CH3, CH3, CH3. Okay, then C double bond CH2, CH2, CH3. Okay, the other product will be like CH3, CH3, CH3. Okay, then CH3 double bond CH, CH3. So look, CH3, C, CH3, CH3, C, CH3. This bromine has gone, okay, as bromide. Then CH, hydrogen bond, so double bond CH, CH3. Okay. Again, look at this. The other one, CH3, C, CH3, CH3, C. Bromide is gone. Then here this hydrogen is gone. One hydrogen is gone, so you get a double bond. Then the rest you have two hydrogens. Okay, CH2, CH3. Okay. So I hope this is clear. So here you need to find the major and the minor product. Okay. So you need to find the major and the minor product. Here what you can see, here it will be disubstituted one. You look at the doubly bond carbon atoms. This is alkyl group. This is alkyl group. Here to this carbon, two hydrogens are attached. Okay. So this is disubstituted one. And look at this. Here to this carbon, two alkyl groups attached. One alkyl group attached. One is hydrogen. So basically, here when you consider the alkyl groups attached to the doubly bond carbon atoms over here, what you get is 1, 2. Two alkyl groups attached, right? This alkyl group attached. This alkyl group attached to this carbon. To this carbon atom, hydrogen attached. So basically, two alkyl groups are attached to the doubly bonded carbon atoms. And here what you can see, two alkyl groups attached, one alkyl group attached, the other is hydrogen. So three alkyl groups. So in this case, three alkyl groups are attached to the doubly bonded carbon atom. So which will be the major product? As per CBSE rule, this will be the major product. And this will be the minor product. Okay, so I hope this much is clear for you. Okay.